Okay, hello everyone. So this session today we'll discuss what's called repetition or loops. Uh, this is when you want to repeat the same message over and over again, or as long as something is true. So it's called repetition or it's called loops. There, uh, we will talk about what's called while, do while, and do until, which is really not used. And then we have the for loop, count control loop, and then calculating a running total, and sentinels, which is basically a way to stop the loop based on a user's input. And then we have nested loops, which is called a loop inside another loop. Now, a repetition is a structure causes a statement or a set of statements to execute repeatedly. Like, for example, I kind of mentioned last class, um, in the case of, let's say, a for loop, we discussed about Simpson, right? His teachers will make him repeat, I will not do this 100 times. You know how many times you want. So something like that, it would be something like, for example, I will not do this again. You can easily make a mistake on the spelling on 100 lines. But if you had to write it in a computer program, you can write that statement once and just repeat it how many times that you want. Okay, so allow a program to avoid duplicate code. Duplicate of code makes a program a large and a long sequence of statements. It's time consuming. Like, for example, if you had to write that, I will not do this again 100 times, it takes a long time. But with loops or repetitions, you can write it once and then run it and say how many times you want it to run. If part of the duplicate code has to be corrected or changed, then the change has to be done many times. So there are multiple misspellings, then you have to go all of those and fix it. But if it was only one line, you can directly go to that line and fix that. We have what's called a while loop. So it's if the condition is true, do some task. Then we have a do while loop, do some task while the condition is true. Then you have do until, do some task while the condition is false or until it's true, which is barely used right now. With all loops, be careful not to create infinite loops. Always provide a way to break out. So I kind of gave you an example last class, a while loop. So this is while a condition is true, do some task. So here, while the condition is true, do some tasks. So we give the example of a drive-through, right? So the first, you go through a drive-through, and then drive-through of a restaurant, let's say. The first thing they see that condition to be true is, did you actually pay, right? So they check if you actually paid. And if the first window says, yes, we got paid, we got the money, then do some task, then give them their food. Isn't that what happens? Some of these fast food restaurants. So the first window, it will check, did you actually pay? The answer is yes. The second window is, okay, give them the food. If the first condition becomes false, that you didn't actually pay for it, then they won't give you food, right? So that's basically a while loop. The do while, think of it like a dining restaurant. So the first thing is, they seat you, come on in, and then they'll do what? They give you some bread, some cheese, and they'll give you the menu. Like, you know what? We'll come back. So they actually do what? Do some task, then while the condition is true. So they do that, actually gets executed. They give you some food, like some bread and some cheese, before you actually order the meal. Then they come back to you. Okay, are you ready to order? Like, no, I forgot my wallet. Okay, see you later then, bye. Okay, so at least what happened was they did some task, whether it's a water they brought to you or a bread they brought to you. Then they check the condition of that while the condition is true. But in the beginning, they don't ask you, do you actually have your wallet? Do you actually pay for it? They don't ask you for that. So that is a do while. The do until is basically do some task while the condition is false. Maybe beat you up or lock you down and say, are you guilty or not? Right? So it's really not used this now. Then this is the old language. So with all loops, be careful not to create an infinite loops. Always provide a way to break out. And an example of that is, let's say, is $3 less than $10? And then you write a loop. Then what happens to that loop? $3 will always be less than $10. So the loop keeps on going and going and going and going. So you don't want that. So you want to make sure that you're able to end it at some point. Okay. So a while loop, while a condition is true, do something. So two parts, the condition tested for true or false value, and then statements repeated as long as the condition is true. So you have an inflow chart line goes back to the previous part. The general format is while condition statement. So here you have the condition. If it's true, keep going. Yes, they paid, give them the food. Yes, they paid, give them the food. But if it's false that they didn't pay for it, then get out of that loop. Okay. So in order for a loop to stop executing, something has to happen, right, inside the loop to make the condition false. So iteration is one execution of the body of the loop. So while loop is known as pre-test loop, test conditions before the performing an iteration, meaning that make sure that you actually get paid. Will never execute if the condition is false. You don't get the food. To start with, requires performing some steps prior to that loop. You have conditional control loops, so working with modules and loops. So to run a program multiple times, module can be put within a loop. Module means a function, some part of code that belong together. So here you have a start, and part of the assignments we'll be going over functions and modules. Then you have a start, you have declare string, keep going. If the answer is yes, and then you go through if the answer keep going is yes, then you execute that module or that function, and then do you want to calculate or whatever you want to do with that function. If it's false, it will end that loop. Then you have the do while, which is basically says do and then some statements while the condition is true. So meaning that you start, declare strike, keep going, and then here you have the module or the function. Do you want to calculate? So it's doing something, then it checks after that. Basically, think of it that yes, you have got all this food, the drink, the water, the bread. If it's true, okay, keep doing it. Oh, they don't have any money, then exit. Basically, if it's false. Okay. So loop, the do until loop iterates until a condition is true, but not all languages support this type of loop, like I was saying. So most of the high-level languages don't support this anymore. So the condition, if it's true, it will exit. If it's false, then keeps on executing the statements. Infinite loops. So loops must contain within themselves a way to terminate. So something inside a while loop must eventually make the condition false. So infinite loop that does not have a way of looping, so repeats until a program is interrupted. So of course, when a programmer forgets to include a stopping code in the loop. In the past, you would have to stop the whole computer, because they didn't have the operating system, they didn't have a mechanism to stop it. Right now, you can actually close that window if it drives you, if it just keeps on running. Then we have the for loop count control loop. Okay? So it iterates a specific number of times. Like in the case of the example that I give you about Bart Simpson, you can say 100 times or 5 times. You know how many times you want this thing to run. Okay. So you use a for loop statement to write a count control loop. So designed to work with a sequence of data items, iterates once for each item in the sequence. So general format is for variable n and then statements. So target variable, so the variable which is the target of the assignment at the beginning of each iteration. So you have the count control loops. So for loops can also increment by more than one. Count backwards by decrementing or allow the user to control the number of iterations. So you have a start, you declare how many times you want, you start with 1, and then you say it's less than whatever the maximum is, which is here. If it's false, exit. If it's true, keep repeating until it reaches the maximum. Okay. So an example of first iteration, for number n, print none. Second iteration, and then it keeps going, third iteration, until it gets to it, the last one. So the range function simplifies the process of writing a for loop. So range is a built-in function you can use with for loop. So range returns an iterable object. So iterable contains a sequence of values that can be iterated over. So the characteristics is 1 argument used as ending limit, 2 arguments starting value and ending limit, 3 arguments, third argument is a step value. So the purpose of target variable is to reference each item in a sequence as the loop iterates, and the target variable can be used in calculation of tasks in the body of the loop. So an example is calculating the square root of each number in a range. So the general loop concerns for count control loops is do not forget to initialize it. Like you want to say, what number do you want to start with? You want to start with 0, you want to start with 1. the loop control variable. Do not forget to modify the loop control variable. Many loops are interchangeable, but generally you use a while loop when loop may not have to process. They don't have to give you food, right? So you use a while loop. You use do while when it must process at least once. Like in the case of a dining restaurant, they have to sit you down and give you water, then you use a do while. You use a for loop with a specific number of iterations. You know how many times you want to run it. You only need 5 times for this statement to run. Then in that case, or 100 times, then in that case you use a for loop. Now, sometimes the programmer does not know exactly how many times the loop will execute. Then you can receive a range input from the user, place them in a variable, and call the range function in the for clause using these variables. So you be sure to consider the end cases, like range doesn't include the ending limit. Sentinel is a special value that marks the end of a list of values used as a stop value for loops. So how it can be done: ask the user at the end of each loop iteration if there is another value to process. Ask the user at the beginning of the loop how many times the loop should process. One of your last labs, I believe, what you have to do is ask the question, is there another customer? Because you don't know how many customers you'll be serving that day, right? They'll be buying from your restaurant or your food truck. So you have to ask, and you use a Sentinel there. As long as the answer is yes, there is another customer, then you continue with that loop. And once you put the answer no, or you have some numbers like the 1 or 2, and then you say that ends the program, then it will end the loop. So your last lab requires that you use a Sentinel. So generating an iterable sequence that ranges from highest to lowest. So the range function can be used to generate a sequence with numbers in descending order. And here you have to make sure the starting number is larger than the end limit, and the step value is negative. You have what's called calculating a running total. So programs often need to calculate a total of series of numbers. Again, you will use something like this in your last lab, which you have to calculate all the money you have collected for that day, or the number of customers that you have served for that day. So typically includes 2 elements: a loop that reads each number in the series, and an accumulator variable, which basically accumulates all the data, known as a program that keeps running a total, accumulates total, and reads in series. So at the end of loop, accumulator will reference the total. Okay, you will do this in your last lab. Okay. So a running total is a sum of numbers that accumulates with each iteration of a loop. So you have a start, you declare how you want it to be. This program calculates. In your case, it will be the total revenue that came in, and then the total customers you have served. Then you set up a counter, okay, as your first customer, and then you set, as long as the counter is less than whatever number that you have served for that day, and it will keep going. If it's true, it will enter, and then it keeps looping in. If it's false, it will exit. We have what's called the augmented assignment operators. So this, in many assignment statements, the variable on the left side of the equal sign operator also appears on the right side of the operator. So augmented assignments operators, a special set of operators designed for this type of job. It's a shorthand operator. So this is an example. So plus equal to. So you write it like this: x plus equal to 5, meaning that whatever x is, add to it 5. So minus equal to means y minus equal to 2. That means whatever y is, minus 2. Whatever z is, multiply by 10, and so forth. Okay. Whatever c is the module of 3. Okay. Or another way of saying the remainder of it. Okay. You have nested loops, which is basically a loop inside a loop. You can set, all loops can be nested. That is, okay, a loop that's inside another loop. Okay, let's go over how these loops work with Raptor flowchart. So this is the one we will use for loops. Remember, the top one is what we used last class. So this loops, this is the symbol. We drag this here. It's asking us to save. Call it test. Save it on the desktop. So you have something like that. So whatever you want to test, you put it in here. So we can initialize something, let's say, and let's say something like total, like that, I guess, in the case that you're doing. Then here, set that to be 50. Okay. We are saying the total is 50. basically like I'm trying to see something you can use, right? In you. Now here, so here is where we test the loop, right? So here we can say if total is less than or equal to 50, actually the other way around, right? If total is greater than or equal to 50, right? Because that means the money is enough, right? Then we can put an output. And say, thank you. You have given us enough money, whatever you want to say. I'm just giving you an output. It doesn't necessarily have to say the output. But if the money is not enough, okay, you want to put a message out. Money is not enough. Okay. Put plus sign, right? And then say maybe total. And then add, give me more money. Something like that. Now here I said total. We can make it an input if we wanted to. So let's quickly run this. Right now it's saved as a variable. You would want to make it, of course, as an input. But if we run it, watch what happens. It goes through here because we hard-coded it. Automatically, it will say what? Because we hard-coded it, it will just say what?
Thank you, you have given us enough money.
Right? But because it's hard-coded, I can say 20 here. But if I say 20, it would go the other way around. Watch what happens. It fails, so it will go the other way around. It will say, what? Money is not enough. Give me more money. What happens here? Why? This is an example of what? Infinite loop, because this would always be what? True. So we want to avoid that. This is an example of an infinite loop. So what's the best way then here? To have instead an input. So in that input we'll say, give me money, right? Or you can say whatever they have to pay, right? Then here we can assign that variable, total, get rid of this one in that case.
Doesn't the input have to be in the loop?
Say it again?
Doesn't the input have to be in the loop?
No, this is a question from outside first, right? Now here it says give me money. If I give 20, it will go back. That's what, this continues, right? So you ask that question here again. You have two choices. So we can drag this here and stop it. We can drag that here, right? And then initialize it here if you want it. So let's run it, right? Now give me the money, 20. Oh, give me the money, guys, not enough. You can say here the actual money they own by adding a plus sign with the variable, right? Give me the money. Now if I give 50, again here I said 50, but you want to say whatever the total is, right? Or the cash tender. You want to create another variable called cash tender. So it will say now, thank you, you have given me enough money. So if it's true, it will exit, it will say thank you, but if it's false, it's expecting 50. In your case, instead of just saying 50, you will say cash tender or something. Because you want to compare the total with the money that's given to you. Does that make sense? So here I'm saying total, but here you can say instead of assigning a total, assign it as a cash tender or something like that. Okay, so this is how the loops works. If it's true, it will execute. If it's false, it will keep going back. Okay. Same thing. Let's say total maybe, and then say int, and then maybe input how much are you giving me? And while total is less than or equal to 50, and say print, they're giving me, change the screen if you want. They have given me enough money. You can just do that, and then ask the same question. This is what I was referring to earlier with your question. So you can ask the same question again for total, and then you say input. How much money are you giving me? And then now you can exit that, and then say print. Thank you. You have given me enough money. So how much money are you giving me? So how about 10? So how much money are you giving me? I mean, you can define the message. It will keep repeating. But if I give 60, it will say thank you. You have given me enough money. Okay. So again, yes, you start with the question in the beginning, like in the case of you asking for money, and then if it fails, you ask the same question inside your loop, and then if it doesn't fall, then you say, okay, you passed. Thank you. You have given me enough money. Does that make sense? So, and again, the loop depends on however your logic is, however you set it up, however you're thinking. You can set it up when it's less than or when it's greater than, based on your thinking or your logic.